Hello class. So this lesson or lesson for today is about life safety systems in buildings. This lesson will mainly focus on fire suppression in buildings and the equipment used in buildings in order to suppress and to alert people in buildings about the hazard of fire. Fire is a combustion reaction that requires oxygen, heat, and fuel. So without any if you miss any of these three elements, there will be there will be no fire. For example, there is no oxygen, there's only heat and fuel, no fire will occur. Typically, a spark or flame ignites the fire, beginning the combustion reaction. In order for combustion to continue, there must be sufficient heat given off by the reaction and a proper blend of oxygen and fuel. The piloted ignition temperature of a fuel is the temperature at which a fire can start when a flame or spark begins the combustion reaction. Meanwhile, the auto-ignition temperature, or sometimes called the spontaneous ignition temperature, is the lowest temperature at which a combustible material ignites in air without a spark or flame. There are four stages in the progression of fire: ignition, flame spread, flashover, and consumption. The first stage of any fire begins with the ignition of a fuel source. Ignition requires the proper blend of oxygen, heat, and fuel. The second stage is the flame spread, which is the characteristic of rapid crawling tongues of fire that lick across the surface of walls, ceilings, floors, and supporting timbers. When the mixture of gases and air reach critical proportions, the material ignites in a great ball of fire called the flashover stage. During the flashover stage, the fire might reach explosive proportions. The final stage in the burning sequence is the fury consumption of the material itself as it burns the ash. Generally, fires are classified into four groups by type of fuel. Group A are the ordinary combustibles like wood, paper, plastic, trash, grass, and so on, mainly the solid materials that can be combustible. Group B, flammable liquids, gasoline, oil, grease, acetone, and etc. Group C, electrical equipment, like any faulty electrical wiring, connection equipment, and so on. And Group D are the combustible metals like potassium, sodium, aluminum, magnesium, and so on. So just remember Group A, solids, not including flammable metals. Group B, liquids. Group C, electrical. And Group D, solids but metals. So extinguishing a building fire is more complex than quenching a content fire. The spreading flames that are sometimes concealed must be located and disrupted in addition to extinguishing the original content fire. To accomplish this effectively, the firefighter must know the various ways fire can be spread throughout a building structure. So we have different materials in a building that can catch fire, and um, they all behave differently in the occurrence of fire. One example of this is steel, which is a non-combustible material yet displays a significant loss in strength in high temperatures. Structural steel loses about half of its strength at a temperature of about 950 degrees Fahrenheit or 510 degrees Celsius. At temperatures of about 1350 degrees Fahrenheit or 730 degrees Celsius, steel loses about 90% of its strength. As a result, structural steel is typically protected from fire by an insulating layer of fire-resisting material. Lumber and timber, which are all kinds of wood, are good insulators. But when it is exposed to fire at temperatures as low as 300 degrees Fahrenheit or 150 degrees Celsius, it will burn until it is destroyed. In a fire, wood loses strength by charring. In a fire, wood loses strength by charring. The reduction in effective cross-sectional area is dependent on the number of places exposed to fire. Fire, fired clay masonry or brick and other fired clay products are vitrified in kiln or oven at high temperatures during their manufacture. As a result, fired clay masonry units are relatively stable in a fire endurance test. Brick also displays reasonably good thermal performance. One of the more significant reasons one of the more significant factors in the fire endurance of hollow brick masonry is the amount of solid material in the wall thickness. Concrete, which is similar to brick in thermal performance, loses strength gradually during exposure to high temperatures. It retains about half its original strength at 950 degrees Fahrenheit or 510 degrees Celsius, and one third of its original strength at about 1300 degrees Fahrenheit or 700 degrees Celsius. This this loss of strength is irreversible because it is from the deterioration of the cement binder and, in some cases, degradation of the aggregate. We have several types of building construction um, according to their resistance in fire. So type 1 is fire resistive, which is the least combustible, and it is characterized by non-combustible walls, ceilings and floor assemblies, concrete, masonry, and protected steel walls, floor, and structural framework. Roof covering is also non-combustible. Type 2 is non-combustible, a little bit more combustible than type 1. They are composed of non-combustible steel or concrete walls, floors, and structural framework. Roof covering is combustible. Type 3 is ordinary. So as you can see, as we go from type 1 to type 5, the materials become more and more combustible than the first one. So it is type 3 is composed of non-combustible masonry bearing walls, but the floors, structural framework, and roof can be made of wood or another combustible materials. Type 4 is heavy timber, which is composed of structure which consists of large solid wood timbers. And lastly, type 5 is wood frame, which is the most combustible, with interior framing and exterior walls constructed of slender repetitive wood studs, joists, rafters, and trusses that burn very rapidly. Although heat alone can prove deadly to occupants, toxic Toxic gases and smoke cause the majority of deaths and injuries. About half of all the fatalities from fires are from carbon monoxide poisoning, and more than a third are from cardiopulmonary complications. So, passive fire protection in buildings involves constructing walls, floors, ceilings, beams, columns, and shaft enclosures so that they can resist, control, and contain the damaging effects of fire. It is intended to entail the following. Number one, provide structural and thermal integrity in the floor, wall, and ceiling assemblies during a fire for a specified time period. Number two, compartmentalize a room or space to control the fire spread. And number three, to provide exiting systems for occupants to safely and rapidly evacuate the building. A principal objective of fire-resistive construction is to use the materials and construction assemblies that contain the fire in a small area and confine the fire in a room or area for a specific period of time. So, fire-resistive construction provides protection for a specific time period so building occupants can be made aware of the fire, the occupants can be evacuated from the building, and firefighters can fight the fire. Compartmentalizing means separating a building into compartments so that if there is a fire, the fire damage is confined to a certain room or a certain section of the building only. Firewalls are fire-rated walls that form a required barrier to restrict the spread of fire throughout a building. A fire separation is similar to a firewall except that it does not intend for the foundation it does not extend from the foundation to the roof assembly. A shaft wall is a protective fire-rated enclosure around an elevator hoist, way, or mechanical chase. And a fire stop is a specific construction technique consisting of all materials that fill the opening around the penetrating items such as cable trays, conduits, ducts, and pipes, and their means of support through the wall or floor to prevent the spread of fire. Gypsum wallboard is a fire protective covering that consists of approximately 21% water chemically bonded to calcium sulfate. In a fire, a large amount of energy is released to evaporate water in the gypsum material, giving it excellent fire protective qualities. Insulating materials, including rock wool, a fibrous insulation made from volcanic rock, and vermiculite, a natural insulating material, also functions well. Concrete and masonry also serve well as fire protective coverings. An intumescent material enlarges, inflates, and expands when exposed to heat. These intumescent uh, coatings expand approximately 15 to 30 times their volume when exposed to high temperatures in a fire, and thus provide a good fire protective barrier. Fire doors are typically of steel or solid wood construction and are installed with specially tested components including closers, latching hardware, and fire-rated glass lights like windows. Intumescent seals are fitted to the edge of the door leaf or in the frame reveal. An intumescent seal expands in fire to seal the gap between the edge of the leaf and the frame, as a result preventing the passage of smoke and flame. Fire-resistant glass can be classified into two categories: insulating and transmitting glass. Fire-resistant heat-transmitting glass contains inflammable gas for a short period of time but does not prevent the transmission of heat to the other side of the glazing, like ward glass, reinforced laminated glass. Fire-resistant insulating glasses contain flames and inflammable gas for a longer period of time and prevents not only the transmission of flames and smoke but also the heat to the other side of glazing. Fire dampers automatically close to obstruct smoke and fire from a building blaze. Smoke dampers close upon detection of smoke, preventing the circulation of air and smoke through a duct or a ventilation opening. Several fire and smoke ratings are used to classify the behavior of or and performance in a fire. Common ratings include the following. So this table shows the different construction assemblies with the corresponding fire resistive rating. So the higher the fire resistive rating is, the thicker the material, and that could be accounted for the ability of the materials to resist fire for a longer period of time. So in the earlier slide, we there those are the ratings for walls, and in this table we have the ratings for floors or ceilings and steel columns. And this slide includes the fire rating for the steel doors and wood doors. The flame spread rating describes the surface burning characteristics of a building material. The most widely accepted flame spread classification system is specified in the NFPA, or National Fire Protection Act Life Safety Code, or NFPA number 101. So class A or 1, so the letters correspond to the NFPA rating, and the numbers, Roman numerals, corresponds to the international rating. So class A or 1 has a flame spread of 0 to 25, and they have a good resistance to flame spread. Class B or 2 have a flame spread of 26 to 75, fair resistance to flame spread, and class C or 3 has flame spread of 76 to 200 and has poor resistance to flame spread. So as the the rating goes down from class A to class B, the flame spread index increases, and that indicates that the material is has poorer resistance to flame spread. So in this table, we have the different kinds of materials or constructions and their flame flame spread rating and their class. So as you can see, brick has a flame rating of 0, and it is of class A or 1, and we have the weakest material against fire, which is wood structural panels with a rating of 76 to 200. The smoke developed rating is a single number classification of a building material as determined by the ASTM E84 test of its surface burning characteristics. It is expressed as the ratio of the smoke emitted by a burning material to the smoke emitted by the red oak standard material. So we have talked about the passive fire protection. Now we also have the active fire protection, the suppression. So passive fire protection is about building a using building materials that resist fire passively, but we also need to actively suppress the fire when the situation gets out of control. So active protection systems include standpipes, sprinklers, and spray systems designed to extinguish the fire outright or control the fire by delaying its damaging effects. Types of firefighting media include water, foams, inert gases, and chemical powders. A standpipe system is an internal piping network connected to fire hose stations that are used to rapidly suppress a fire. Firefighters can use hoses connected to the standpipe system or connect those hoses to valve outlets near the fire. We have several types of standpipes, and one is the wet standpipe, has which has always has water in its piping. The water in the system is always under pressure. In some cases, a fire pump may be used to increase the water pressure. The wet pipe system is the most commonly used standpipe system. Meanwhile, the dry standpipe with an automatic dry pipe valve is the system that is usually supplied with a public water main by a public water main. Under normal conditions, there is no water in the piping, but instead there is air under pressure in the piping. A dry pipe valve is installed to prevent water from entering the standpipe system. The dry pipe valve is designed to open when there is a drop of air pressure in the standpipe. That is when you open when the air is removed the from the dry standpipe. This system is usually installed in buildings that is not heated. So this kind of of standpipe is used when the building is located in a place where the temperatures can drop into freezing water temperatures. Meanwhile, the dry standpipe with the manual control valve is a system that is supplied by a public water main. Under normal conditions, the system has no water in the piping. The water is not allowed into the standpipe until a control valve is manually operated. The control valve remains closed until a fire occurs. This system is usually used in a building that is not heated. And lastly, the dry standpipe with no permanent water supply is a system that has no water in the piping. Water is pumped into the standpipe system by a local fire department. The water is pumped in through a Siamese connection. This system cannot be used unless water is supplied by a department. Standpipe systems are classified depending on who is expected to use the system. Class 1 system is designed for use of professional firefighters. The fire hoses in these systems are 2.5 inches in diameter. The large hose diameter makes it difficult to control the stream of water from the hose. Class 2 system is designed for use by the occupants of a building. The hose and nozzle are connected to the standpipe. They are ready to be used by occupants in case of fire. The hose is 1.5 inch in diameter. The hose stream is easier to control than the Class 1 hose. Class 3 system may be used by either professional firefighters or by occupants of the building. The hoses may be adjusted to either 1.5 or 2.5 inches in diameter. Attaching special reducing valves to the hose line does this. An automatic fire protection system provides a warning to occupants of the building, notifies emergency personnel responding to the alarm, and activates fire suppression systems to reduce the growth rate of the fire or the movement of smoke. Typically, smoke detectors sense the presence of fire in the building. The fire control panel then sounds an alarm, shuts down air handling equipment, disconnects power from the protected equipment, and then releases agent into the protected area. Fire suppression systems are intended to extinguish or control a fire. These include automatic water sprinkler systems and systems that use a gas agent or foam to eliminate oxygen and suffocate the fire. Smoke control systems are designed to limit the spread of the smoke and to maintain passable occupant egress routes for a given period of time and to aid firefighters in fighting the fire. An automatic sprinkler system consists of the sprinkler heads and a network of pipes placed in a horizontal pattern near the ceiling that is designed to automatically dispense water and fire. The wet pipe automatic sprinkler system have pressurized water in the pipe and mains. Water is released when the sprinkler head is activated. Because of the potential for freezing, this system is suitable for buildings where indoor ambient temperature is not lower than about 40 degrees Fahrenheit or 5 degrees Celsius. Wet pipe sprinkler systems are the most common in use today. Dry pipe automatic sprinkler system have pipes filled with compressed air or nitrogen. The pressure in these lines is slightly above the water pressure, and this pressure difference is what keeps the water out of the sprinkler lines. When a sprinkler head is activated, the air will begin to be released and the air pressure will drop. The pre-action automatic sprinkler systems are similar to a dry pipe except that the water first fills the pipe as the alarm is set off, providing an opportunity to extinguish the fire manually before the sprinklers open. Water is stopped at feeders in the walls before the pipe supplying the sprinkler heads by a valve. This valve is electronically activated by a heat detecting device within the area, and a signal is sent to the valve and the valve opens. Water will then flow to all heads but will only discharge through the activated heads. The pre-action sprinkler system is often used where the use of sprinklers could cause extensive material or equipment damage, such as in retail stores and computer areas. The deluge automatic sprinkler systems allow all sprinkler heads to go off at the same time. This system is very similar to the pre-action system, except that all sprinkler heads are open. In conventional systems, individual fire sprinklers are spaced throughout the ceiling of a building at a predetermined interval or position. Most sprinklers have a 1-inch discharge opening. Each sprinkler can cover approximately 100 square feet. Sprinkler heads are usually positioned upright, pendant or pointing downward, or sidewall or pointing sideways. Most commonly used is the pendant type, which hangs below the pipes. Once activated, conventional sprinklers continue to run until the main valve is manually closed. This can result in excessive water damage, one of the major causes of property loss in fires. Flo- Flow control sprinklers close automatically once the ceiling temperatures are reduced. Many of the sprinkler heads are reactivated if the temperature goes back up. Regardless of the type of sprinkler head, they must be replaced after they have been activated. The types of pipe approved for use in sprinkler operation include the following. Steel pipe are approved for use in all fire suppression sprinkler applications. Copper tubing is the most popular water supply pipe material, but it is used less frequently in the fire sprinkler systems. Chlorinated polyvinyl chloride or CPVC is a rigid plastic pipe generally approved for use in fire suppression sprinkler systems in residential and many light commercial applications. Um, the water supply for sprinkler systems can come from mainly, majority of them come from a gravity storage tank that may be located on the top of a building or on a tall tower. Pressure tanks are often used where there is enough water from a supply source, but the water pressure is too low, or in tall buildings that need the extra water pressure to supply the highest line of sprinklers or the highest line of hoses. A fire pump is a part of a fire sprinkler system's water supply in high-rise installations where the local public water system cannot provide sufficient pressure, where systems require high pressure at the fire sprinkler in order to flow a large volume of water. Um, Example is a large warehouse or manufacturing plant where water is from a storage tank. We also have alternative fire suppression systems because the traditional standpipe system, the traditional sprinkler system can use a lot of water to suppress the fire. So one example is the water mist automatic sprinkler system which relies upon a fine spray of water to suppress fire. The mist, with its small droplets of water, is very efficient in absorbing a large amount of heat as the droplets contact the fire and is converted to steam. Another is the clean agent gas fire suppression system, which discharges a gas on the surface of combusting materials. Clean agent gases can be released in a building space without leaving residue. When released, they extinguish the fire rapidly but do little harm to building occupants, firefighters, interior contents, and equipment. The carbon dioxide fire suppression system discharges a carbon dioxide gas that extinguishes fire by displacing oxygen or taking oxygen away from the fire. Carbon dioxide is also very cold as it comes out of the extinguisher, so it also cools the fuel. The foam fire suppression system discharges a high volume of gas-filled bubbles that rapidly fill a space. Foam masses are lighter than water in flammable liquids, and they may be either air or chemical gas bubbles. They float on the surface of burning liquids to deplete oxygen and smother the fire. Um, Portable fire extinguisher can also be a means to suppress fire. There are four classifications of these extinguishers. Class A is suitable for extinguishing Class A fires, which is caused by ordinary combustibles such as wood, paper, rubber, trash, plastics, and there is a and where a quenching cooling effect is required. Class B extinguisher is used for extinguishing Class B fires, which is caused by flammable liquids, gases, and grease, and where an oxygen exclusion or flame interruption effect is essential. Meanwhile, Class C extinguisher is used for extinguishing Class C fire, which is caused by energized electrical equipment and wiring, where the dielectric conductivity of the extinguishing agent is of importance. And lastly, Class D extinguisher is suitable for use on fires in combustible materials such as magnesium, titanium, zirconium, sodium, and potassium. Air pressurized water fire extinguishers are large silver tanks filled about two-thirds water and then pressurized with air. They are designed for Class A fires only. Carbon dioxide fire extinguishers are filled with non-flammable carbon dioxide gas under extreme pressure. They are designed for Class B and C fires only, which is the flammable, liquid, and electrical. And the dry chemical fire extinguisher put out fire by coating the fuel with a thin layer of dust, separating the fuel from oxygen in the air. The powder also works to interrupt the chemical reaction of fire, so these extinguishers are extremely effective at putting out fire. They come in a variety of types, ABC and BC. ABC is multi-purpose. It can extinguish class A, B, and C fire, while BC can only extinguish class B and C fire. A smoke control system is an engineered system that uses mechanical fans to produce airflows and pressure differences across smoke barriers to limit and direct smoke movement. It is the part of a fire protection system that manages and directs smoke to protect building occupants and property, both the building and its contents. This system can also be used to assist firefighting activities. Fire alarm systems detect products of combustion such as smoke, like the aerosol particulates, um, heat and light, and provide early occupant notification to allow the safe egress of the occupants. These systems use various methods to detect the products of combustion, including various heat and smoke detection techniques. They use audible and visual alarms to alert and warn the building occupants of a fire. One example is the smoke alarm, which is a fire safety device that detects the products of combustions and gives off an audible and or visual warning to building occupants. It is a smoke detector and an alarm in one unit. They typically use an audible alarm signal to alert and warn building occupants of a fire. The smoke detector is a sensing device that identifies products of combustion in the air. Heat detectors are sensing devices that recognizes a high temperature or a rapid increase in temperature. In large buildings, smoke and heat detectors are placed in building spaces and in the ductwork of air handling units. One such type of smoke and heat detector is the fixed temperature heat detectors that signals an alarm after the temperature at the detector reaches a set value. One example is the fusible alloy detectors that employ metal alloys designed to rapidly melt at the desired temperature. Bimetallic detectors use sensing element made of two strips of different metal, each having different thermal expansion coefficients. When the metallic strips are heated, the sensing element deflects, closing the contact and initiating an alarm. Electrical conductivity detectors have a sensing element in which resistance varies as a function of temperature. Heat-sensitive cable detectors consist of two current-carrying wires separated by a heat-sensitive insulation that softens at the rated temperature, thus allowing the wires to make electrical contact. And liquid expansion detectors have a sensing element comprising of a liquid that expands with the increase of temperature. Rate of rise heat detectors signal an alarm when the temperature at the detector increases at the rate exceeding a preset value. Pneumatic rate of rise detectors have an air chamber with a diaphragm enclosing a portion of the chamber. Electrical conductivity rate of rise detectors have a sensing element that changes its resistance with a change in temperature. Flame detectors optically sense high levels of either infrared radiation or ultraviolet UV radiation. Combination UV IR detectors are also commercially available. Ionization smoke detectors are designed with a sensing chamber that has a radioactive element. Photoelectric smoke detectors use a light scattering or light obscuration principle. They contain a light emitting diode that is adjusted to direct narrow IR light across a unit's detection chamber. Lastly, the air sampling smoke detectors use a similar approach to light obscuration detectors. However, a laser or xenon tube is typically used as a light source. In medium to large buildings and building complexes, a fire detection and alarm system includes all or some of the following: 1. A system control unit. 2. A primary or main electrical power supply. 3. A secondary or standby power supply, usually batteries or an emergency generator. 4. An alarm is initiating device such as an automatic fire detector, manual pull station, or sprinkler system flow devices connected to initiating circuits of the system control unit. 5. Alarm indicating devices such as bells or lights connected to initiating circuits of the system control unit. 6. Ancillary controls such as ventilation shutdown functions connected to output circuits of the system control unit. 7. Remote alarm indication to an external response location such as the fire department. And lastly, control circuits to activate a fire protection system or smoke control system. The fire system control unit serves as a center of the fire alarm system. A fire command center is a remote panel or set of panels connected to the fire system control panels. The command center contains the following: the voice fire alarm system panes and controls, fire department two-way communication service panels, telephone for outside communications, and sprinkler valve and water flow status panels, smoke management controls, elevator location status panels and annunciators, fire pump status panels, and lastly, emergency generator status panels.